This video will show you how to graph a nominal by continuous interaction, and by extension, a continuous by continuous interaction. In this case, I want to know whether the effect of praise on total engagement depends on whether I'm male or female. So I want to have an interaction between male and praise, which I've already done. So let's run the regression. Reset. Right-click, display variable names. Total engagement will be dependent variable. Male. I'll go ahead and control for group as well. And praise. And then my next block, will be the interaction term, the male by praise interaction term. Paste. Find my syntax. And run it. R squared went up a tiny bit, 0.02. It's not looking likely that this interaction matters. And lo and behold, the p-value for the male by praise interaction is 0.321, which means it does not depend. The effect of praise on engagement does not depend on whether you're male or female. Again, notice what happens to the p-value for praise in the presence of the interaction. It becomes very high. You cannot trust the p-values of your parent terms in the presence of an interaction. You have to go to the previous model where the interaction is not run in order to really understand the relationship between praise and the outcome. For the sake of argument, we're going to pretend that the interaction is indeed significant, just so I can show you how to graph it. Left-click on your coefficients. Export, browse. We'll call this male by praise interaction. Click Save. Make sure this thing is checked, and so it'll open the containing folder for you once it's done, and click OK. The SPSS will think about it. Now open the folder. So male praise interaction. And there we are. We have both models, Model 1 without the interaction and Model 2 with the interaction. We're going to pretend that Model 2 is that the interaction term really is significant, and make my 4-point matrix. So I'm going to have male up here, or excuse me, gender, with the two values of gender like we did in the previous video, male and female. And then we're going to have praise over here. We're going to call it high praise and low praise. Now what value should I plug in here? Well, in order to answer that question, we need to go back to the data. So let's go back to SPSS and request the mean and standard deviation of my praise variable. Alright, so as the mean of 0, that makes sense because I centered the praise variable before I did it. And I have the standard deviation of 0.805. So let me write that number down in Excel. 0.805. Generally, the two values that you call high praise and low praise, let me move them over, are one standard deviation below the mean and one standard deviation above the mean. My mean is 0 because I centered it. My standard deviation is 0.805. And so 0 minus or plus 0.805 is going to be 805, and 0 minus one standard deviation, 0.805, is negative 0.805. So I have my two values for gender and praise. Excuse me, two values for praise and my two values for gender. Let's write the equation one more time. So I have engagement is equal to beta naught plus beta 1 times gender plus beta 2 times group plus beta 3 times praise plus beta 4 times praise by gender interaction. Again, I have this extra term like I had in the previous video. We have this extra term of target, or of group. which is not involved in interaction. What do I do with it? Generally, you want this term to go away if possible. So I will call my interaction plot will be interaction for those students in the control group, where grouping is equal to 0. And so that term will vanish. The graph will look the same whether I choose grouping equals 0 or 1. Just the intercept or the constant will be shifted up or down depending on what this coefficient is. So let's go ahead and do the equation, the new equation with group gone. Engagement is equal to beta naught plus beta 1 times gender plus beta 3 times praise plus beta 4 times praise times gender, and do what I did in the previous video. The only difference is instead of 0s and 1s everywhere, I have these standard deviation values. So if I had a continuous interaction, I would simply have -1 standard deviation here and 1 plus 1 standard deviation here instead of 0 and 1 like I have for a dichotomous. So I put equals, find the intercept, bracket it around in dollar signs to hold that cell constant, plus gender, bracket that around in dollar signs, times the value that gender actually takes on. Make sure you hold the row constant, allow the column to vary, plus the beta for praise, target vanishes, put dollar signs around the beta for praise, times the value for praise, which is 0.805. Make sure that you keep that column constant, so put a dollar sign in front of the column and allow the row to vary, plus the interaction term, put dollar signs around both the row and the column for that, times the value for male. Make sure you allow the column to vary but not the row, times the value for praise. Allow the row to vary but not the column. Yeah. And I get my value. So we drag this down. I get my 4 values for my prediction matrix. Now we just need to graph it. So I go to Insert, find my lane plot. Oops, did that wrong? Get rid of that. Insert line plot. Oh, I guess it's different this time. Move this down. Let's do select data. Select my entire predictor matrix. Click OK. Clean it up by adding a legend and axis titles. The axis title is going to be gender. Move this over. And engagement. Might want to alter your values in these cells to show that high praise is plus 1 standard deviation. So that'll show up in the legend, and low praise will be minus 1 standard deviation. The chart title is going to be difficult to write. Interaction between gender and praise for those students in the control group. Now let's see what story this is telling. So for those for low praise, it matters for males and females. Females actually do, the males apparently suffer from the low praise much more than the females. While the high praise, the differences between the genders is all that obvious. Nevertheless, these differences could have happened by chance alone because the p-value is so high.